The city was faced with a problem of serious flooding in this neighborhood and decided to bring in engineered concrete structures to design and install a system that could handle this amount of water.
Basically, the Pepperwood subdivision has experienced significant flooding over the past few years due to undersized storm sewers that were okay for their original design year, but due to current design standards were inadequate and undersized, and during heavy rain events it resulted in massive flooding. Wade Trim was hired by the city to conduct a study to come up with different alternatives to solve the residents' flooding problems. Then we met with ECS and they introduced us to their cast-in-place watershed system and thought that'd be a perfect fit and encouraged them to talk with city officials to be included within the project specifications.
There were several options on the table, and ECS was ultimately chosen because of our very compact geometry and low maintenance costs. The ECS watershed system detains the water for a specified time and then releases the water into the natural waterway. In this case, ECS was able to combine a previously external flow control structure into our stormwater detention structure. The benefit of this combination was a reduced footprint and our ability to control the water flow into the natural waterway all within one structure.
It's extremely flexible where you can build whatever you want in the field. They, A, are competitive with pre-manufactured systems, and B, they are competitive with installation time.
The ECS watershed system has proved to benefit customers because it is the only system on the market that may be designed for an interior rise of greater than 10 feet. This allows the customer to use a smaller footprint, which reduces excavation, backfill, and ultimately minimizes the impact on the area of the project. Once the hole is prepared and the subgrade material is placed, ECS jumps into action. Our first step is to place edge forms around the perimeter of the structure. Then, ECS flies roll mats of reinforcing steel into place and rolls them out in both directions. The next step would be to tie perimeter dowels around the edges of the structure and then along the interior wall lines. Then, ECS sets grade and commences to pour the concrete via concrete pump. After the base slab is placed, ECS starts forming and pouring the walls and deck monolithically. Longitudinal steel runs continuously through construction joints. Due to our forming method, joints between walls and decks are eliminated, thereby increasing structural integrity. When the application requires a waterproof structure, ECS furnishes and installs PVC or bentonite water stop to the joints to make them watertight. Finally, heavy equipment is brought in to backfill, pavement is completed, and the road is opened. Real estate in an ultra-urban setting is worth a lot of money. Because of its design flexibility, watershed simply takes up less space. Therefore, it delivers a lot of value.
Well, I think that the main advantage is that the cast-in-place system had a lot more flexibility as opposed to pre-manufactured system in configuring the system requirements, which resulted in a much smaller footprint than the pre-manufacturing required.
ECS is really good at concrete formwork. That is our core competency. We can build structures of any shape and any size. What we had to do here, we could do because nobody else could, and that is make a system that would fit a very difficult site and make it work. And that's exactly what we did.